Hello everyone, this is Dr. P. Mahalakshmi, Assistant Professor, Department of Artificial Intelligence and Data Science. Today, we are going to see the lecture about the concept Digital and Mobile Forensics. Subject code is CCS343. So in this video, we are going to see about the file system of iOS. So introduction, first we have to know what is APFS. So this APFS is nothing but is a Apple file system, is the latest file system that was developed by Apple for devices such as iPhones, iPads, Mac, Apple TVs and Apple Watches. Before APFS, before Apple file system, Apple used HFS. It's nothing but hierarchical file system. So this hierarchical file system plus file system is used before APFS as a storage technology. So in this video, we are going to see about the concept of file system and iOS. So as storage technology, evolved from hard disk to SSDs and flash memory now. So Apple designed APFS that is used to provide faster performance and better security and improve the reliability. So here this APFS, this Apple file system was introduced in Mac OS and iOS 10.3 and the tvOS 10.2. So why this APFS was introduced? Why we are using, before we used HFS, why we are using this APFS that is used to improve the file access speed, and it is used to support SSD and flash storage efficiently, and it provides stronger encryption, and that is used to increase data reliability and protection. So here in this first slide, it is explaining about the introductions of the APFS, that is Apple file system. Is nothing but it is one of the modern storage management system that is used in the Apple device, that is used to give the features like speed, security and data organization. And next thing is here we have to know about the key features. What are the characteristics or the fundamentals or the key features of Apple file system? The first one is 64-bit inode number. So the APFS employs, it's using 64-bit inode number. So this an inode number is a data structure that stores the information about the files. So that informations like what are the information they are storing in the inode, that will be like a file size, owner details, permissions, what is the creation time, modification time, and where the data blocks is located, the locations of the data blocks. So these kinds of the information will be stored in the 64-bit inode number. So advantages is using this 64-bit inode number, it allowed the Apple file system to support billions of files and directories efficiently. That is a features belongs to the concept of 64-bit inode number. And next feature of Apple file system is optimized for modern storage. So this optimized for SSD storage, that is Apple file systems is specifically designed for SSDs, flash drives and mobile storage. The benefit for the optimized for modern storage is faster file opening, faster copying and reduce wear on SSDs and better storage efficiency. So advantages for that feature of optimized for modern storage: when opening a large video file on the MacBook, SSD and Apple file system retrieves the data much faster than this hierarchical file system. And next one is what partition scheme. So partition scheme here, GPT is a modern partitioning system. The features is using unique identifiers and support large storage devices and provides better reliability than older partition tables. The benefit for this GPT is reduce the risk of the partition corruption. And next features of Apple file system is containers and volumes. So the containers is nothing but storage area that contain the multiple volume. Volume is the logical storage unit inside a container. So example for a TB SSD can have Mac OS volume, data volume, and backup volume. All volumes dynamically share available space. The advantage of the containers and volume feature is no need to manually allocate the fixed spaces. So that is an advantage there in that containers and volumes. And next one is what? Compression algorithms. And the compression algorithm here, that Apple file system support LZFSC and LZVN, that is Limpel Ziv compressions algorithm. Three compression algorithms we are using in this Apple file systems. So the purpose is compress data to save storage spaces. Example is a 100 MB file may occupy less space after compression. So advantages: more storage availability and faster file transfers. And next one is, so these are the key features of Apple file system. The first one is 64-bit inode number, and second one optimized for modern storage, partition scheme, containers and volumes, compressions algorithm. And next here we are going to see about in the slide 3, impact of Apple file system on digital forensics. So here digital forensics involves collecting, preserving, analyzing and presenting the digital evidence. May the digital evidence will be the information about the call logs or SMS chat or WhatsApp chat or email, the kinds of mail. So these all come under the collections of a digital evidence. So digital forensics, what is the impact of the digital forensics in Apple file systems? That only we are going to see here in the slide. So the digital forensics involves collecting, preserving, analyzing and presenting the digital evidence. So this Apple file system introduced both opportunities as well as challenges. So here the advantages for the forensics while collecting the digital evidence from the iOS system. Snapshots preserve evidence and metadata provides a file history. And next one is, it's a better file organization. The challenges, what are the challenges are there in this Apple file system is, it will be the strong encrypted one and multiple storage layers are there and complex volume structures is there. So these are the challenges have to face to collect the digital evidence from the iOS system. So the investigator must understand, the digital forensics investigator, they have to understand the concept of the Apple file system before starting the investigation. And next one is here the full disk encryption, that encryption that is used to convert the readable data into the unreadable data. So encryption means files are stored normally and easy to access. And here the forensics, the next one is here the snapshots and the digital forensics. Snapshot. So what is snapshot? Snapshot is nothing but capture the exact state of the file system at a specific time. So here the snapshots, that is it contain the characteristics is nothing but read only and that cannot be modified and preserve the old data. So the forensics benefits for the snapshots is recover the deleted file easily, track the system changes and preserve the evidence. So for an example, investigation example, a suspect deletes the documents before seizure, that investigators, the suspect deletes the document before seize. So investigator may locate the APF snapshot, access previous file versions and recover the deleted evidence. So here next one is hardware. In this, before we are going to see what is the hardware in APFS, let I conclude the conclusion of the Apple file system. Advantages are, it will be more faster performance, better storage utilization and snapshot support, strong encryption and SSD optimization and enhance the reliability. So these are the advantages we have in this APFS. So the forensics oriented, the investigator, they have to understand containers, volumes, snapshots and encryption. Then only they can effectively examine the digital evidence from the Apple devices. So this APFS is a secure and efficient file system that improves the Apple device performance while introducing new challenges and opportunities for digital forensic investigation. And next one is we are going to see about is evaluations of the iPhone touch screens. So here early iPhone display, the first iPhone launched with 3.5-inch LCD display, that the resolution will be 320 into 480 pixels. Limitations about that feature is a smaller screen and lower resolution and less color accuracy. So here the improvement over the time, here the size, the increased screen size will now it will be 6.5 inches from this 3.5 inches to nowadays we have iPhone and iMacs, we have 6.5 inches, and they improved the resolution too. For starting we have 320 into 480 pixel. Nowadays we have 640 into 960 pixels. They increased. So the advantage will be better viewing angles and better color and improve the brightness. Next is the transitions of OLED. This OLED is nothing but organic light emitting diode. So here, unlike LCD, we are using OLED pixel produce their own light. So here the advantage is better contrast, true black colors and higher brightness and lower power consumption. So the first OLED iPhone is iPhone X. So the marked a major improvement in the smartphone and display quality. So here the type of OLED is PMOLED, is a passive matrix OLED. So here the features of PMOLED, that is passive matrix OLED, control each row sequentially. So simpler design, lower cost and lower resolution. Next type is AMOLED, is active matrix OLED. The characteristics about this AMOLED is each pixel individually controlled, higher resolution, better color quality and faster response time. So this AMOLED is commonly used in premium smartphones. And that OLED variations are the bottom oriented OLED and top oriented OLED, stacked OLED. These are the variations we have under the OLED. So here the bottom is light passes through the bottom layer. The top oriented means light exit through the top layer. And the stack OLED is RGB layers are stacked vertically. Instead of this pixel features a red, green and blue subpixel stacked vertically instead of side by side. So it is enhancing the color accuracy and brightness. And next one is here the touch technology. So here this I've introduced in this iPhone 6s. So function is detect the pressure applied to the screen. So user actions will be light press, medium press and hard press using this quick shortcuts, preview content and faster navigation. So advantages of this touch screen we have provides additional interactions methods. So haptic touch technology is introduced in Apple 11. So that measures how long a user presses the screen. So features about the haptic touches, simpler hardware, lower cost and reliable performance. So the difference from the 3D touch, this 3D touch is a pressure based, and this haptic touch will be based on the time, how long the user touching the screen. Okay, next one is what? Secure enclave. So here the dedicated security co-processor inside in the iPhones. iPhone basically we are using for the business oriented concept. It is inbuilt security co-processors there in that iPhones. So stores fingerprint data, touch ID, the face recognition and encrypted keys. These are the features playing a very important role for the security purpose. So so here I conclude this video. So in this video we saw the informations about the Apple file system, as well as we saw the hardware in the iOS. So next concept let me see in the future video. Thank you so much.